This example is actually very similar to a lot of things you'll see if you ever watch relief packages being delivered. Most commonly you'll see in Africa or in hurricane regions or tornado regions when it's not safe to land a helicopter and the pilot has a package that is dropped out of the plane or the helicopter designed to land at a specific point. So this helicopter is 82 meters above the ground, and the pilot is obviously flying horizontally, has to hit a point that is 96 meters horizontally ahead. So the pilot has to know how far back of the drop point to release based on how fast the pilot's flying and a bunch of other factors that we won't deal with as it complicates the physics a little too much. We'll deal with the simplistic version. Pilot lets the package drop out of the helicopter, and what is the initial velocity of the package relative to the ground? Well, we know if this helicopter is here, the package is going to drop something like that. It is going to go 96 meters horizontally and 82 meters vertically. We want to know how fast this helicopter is flying horizontally. Well, in order to figure that out, we need to know how much time it takes this package to drop. And that's relatively easy to figure out. We know we have an 82 meter drop. Since the package is dropping, it's affected by gravity, so we know the acceleration. And from there, we can figure out how long this package is in the air. So the displacement of the package is 82 meters down. Acceleration of the package due to gravity, 9.8 meters per second squared, down. The time of the fall is what we need to find. And again, we need to read into this question. We know the initial velocity of this package in the downward direction is actually 0. Yes, the pilot is flying, and yes, he has a speed horizontally, but vertically, as this package is dropped, it is 0. So find an equation that works with these variables. Delta D equals VI delta T plus 1/2 A delta T squared. Substituting in, working this out, 0 times delta T is 0. Half times 9.8 would give us 4.9 T squared on the right. Dividing both sides by 4.9, we'd get 16.73 equals T squared. Taking the square root, going to 2 sig figs, we would get a time of 4.1 seconds. So this package takes 4.1 seconds to hit the ground. Now we can go back and figure out how fast horizontally this helicopter is flying. What we know horizontally is, in a projectile, a horizontal velocity is constant, which means we can use one of the simpler equations. V equals delta D over delta T. We know the displacement horizontally is 96 meters. And again, this is where keeping the horizontal and the vertical separated is incredibly important. The time it takes is 4.1 seconds. Dividing that out to 2 sig figs gives us 23 meters per second.